We're now going to go over powers and exponents. So we have a definition here first. We define for a positive integer n, we define a to the nth power to be a times a times a n times. So that's what a to the nth power is. For example, 2 cubed would be 2 times 2 times 2, or 8. We define a to the negative n to be 1 over a to the nth power. So, for example, 2 to the negative third would be 1 over 2 cubed, and that would be 1 over 8, like that. Now be careful, a lot of people confuse a to the negative n with negative a to the n. These are not the same. That's not correct. When the negative is in the exponent, it means you take 1 divided by a to the nth power. We also define a to the 0 power to be 1, for a being a non-zero number. Now just some notation down here and a few definitions. Sometimes you'll see a to the n written as, there's our hat notation again. That's usually what you see when you type it into a calculator or computer. When we look at a to the nth power, we call a the base and n is called the exponent. And we call a to the n the nth power of a. So a few examples down here. We've already looked at 2 of these. So we've already seen that 2 cubed is 2 times 2 times 2, so that is 8. And 2 to the negative 3 is 1 over 2 cubed. We already did that one. 3 to the 4th power would be 3 times 3 times 3 times 3. And that would be, let's see, this is 9. And this is 9, so that's going to be 81. 3 to the negative 2 power, that would be 1 over 3 to the positive 2 power, and so that's going to be 1 over 3 times 3, or 1/9. There you go. Of course, you can evaluate all these on your calculator as well. When you're dealing with negative exponents, it's okay. It's not a problem. Let's just evaluate, for example, 2 to the negative 3rd power. If we go 2 raised to the negative 3, like that, that is 1/8. 1 divided by 8 is 0.125. You don't need parentheses around the negative 3. You could put them around. It wouldn't hurt anything if you went 2 raised to the parenthesis negative 3, close it off. You'll still get 1/8, or 0.125. Alright, so that's what the nth power of a is, for n being an integer. Now here are some properties of exponents. Notice that if we were to evaluate 3 to the 5th power times 3 squared, we would have 5 3's being multiplied, and then times 2 more 3's. So in total here, we would have 7 3's being multiplied. So notice that's the same as 3 to the 5 plus 2 power. Right? So we have this, so it seems like all we would have to do is add those 2 exponents when the base, the 3's, are the same, and that is in fact a rule down here. That's actually number 2 down here from our list of rules. Notice a to the x times a to the y is a to the x plus y. You just have to add the exponents. Now that's only true when the base is the same. Notice we have two A's there. Also take note of this. If you look at 3 to the 5th divided by 3 squared, you're going to have 5 3's divided by 2 3's that are being multiplied. So you see, 2 of these 3's will cancel. Those cancel with 2 of them up here, and you're left with a total of 3 3's. Well, notice this is 3 cubed, or 3 to the 5 minus 2. If we had subtracted the 2 from the 5, we would get 3 cubed. And so that's a rule right down here. That's this rule. If you have a to the x divided by a to the y power, that's a to the x minus y. You subtract the exponents when you have a quotient like this. So that's another rule. And then we have these two that we didn't illustrate with examples, but they're also true. A times b to the x power is a to the x times b to the x power. In other words, you can distribute this x, the exponent here, to the a and to the b, is what you're doing. And then down here, a to the x raised to the y power, now you multiply the exponents together when you have something like this. So those are the rules that we have. Let's take a look at some examples. So let's simplify these into a form, an exponent with a single base. So for example, 4 to the 5th power times 4 cubed. Well, using our rules, that would be 4 to the 5 plus 3, or 4 to the 8th power. Let's look at this one. 2 to the negative 3rd times 2. Okay, well the 2, well there's no exponent here. Well actually there is, it's just not written. This is actually 2 to the 1. 2 is the same as 2 to the 1 power. So this is going to be 2 to the negative 3rd plus 1. And so that's going to be 2 to the negative 2 power. And there we go, we have it in our form that we wanted. Just notice we could actually write that as 1 over 2 squared, or 1/4. Let's take a look at this one. 3 to the 5th divided by 3 cubed. Well, by our rules up here, that's going to be 3 to the 5th minus 3. We subtract the 3, the bottom exponent, the exponent in the denominator, from the exponent in the numerator. So 3 to the 5 minus 3, and that's going to be 3 squared, or 9. Right here, this is going to be 4. Let's see, the exponent in the numerator is 4, so we're going to go 4 minus the exponent in the denominator is negative 7. So that's 4 to the 4 minus negative 7. That's 4 to the 4 plus 7, or 4 to the 11th power, like that. And there we go. Now this one right here might be a little difficult to see. Why is it 4 to the 11th? Well, here's another way you could see it. If you look at this as 4 to the 4th, 4 to the negative 7th is really 1 over 4 to the 7th power, like that, right? Now, if you think of our rules for handling the fractions, we would flip this up and multiply it by 4 to the 4th power. So this is the same as 4 to the 4th times, and we flip this up here, so it's going to be 4 to the 7th over 1, and that's 4 to the 4th times 4 to the 7th. And so you see, that's why we actually add these exponents. Same as over here. This would be 4 to the 11th. Now let's take a look at this. Let's take a look at roots of numbers. So a few definitions here. We define the square root of a. You've probably heard of that before, of course. It's denoted like this. That's the square root of a. Or a to the 1/2 power. These mean the same thing. These are defined to be the number in which the square root of a times the square root of a gives you back a again. Or you could write it like this. For example, the square root of 4 equals 2 because 2 squared gives you back 4. 2 times 2 gives you back 4. In general, for any positive integer n, we define the nth root of a, denoted like this. There's a little n right there. That might be a little hard to see. It's written like this. N right there of a. So that's what we call the nth root of a. Or a to the 1/n power, like that. These are, they mean the same thing. They're defined to be the number in which the nth root of a raised to the nth power gives you back a again. And so also just note that when n is 2, we don't normally write the square root of 2, the square root of a with a 2 there. We just leave the 2 off. So for example, quick example, the cube root of 125 would be 5 because 5 to the 3rd power gives you back 125. Okay, so the cube root of 125 would be 5. We could evaluate that on our calculator as well. Maybe we'll do that quickly right here. Now, if we evaluate 125, so I have that entered here, let me start that over again. 125. Now, your calculator has a square root button on it, but it does not have a cube root button. Right there's the square root. We'll look at that in a second. The cube root is, there's no cube root button on your calculator. So what you'd have to do is you have to raise this to the 1/3 power. 1 divided by 3 like that. And you have to put the exponent in parentheses because it's more than just a single number there. So make sure you put that in parentheses and then hit enter and you get back 5. And by the way, the square root, like if we evaluate the square root of 4, now your calculator has a square root button. Most calculators do. On the TI, it's right above the x squared button there, so we have to hit second and then the x squared. So you see the square root appears. Type in 4, close the parenthesis off, and then hit enter. And there you go. Now if you're using Excel, you don't have a square root button on your keyboard. You have to raise everything to the 1/2 power or the 1/3 power like we did right here with 125. That's what you would have to do. Alright, so let's continue. For a positive integer n, we define a to the negative 1/n to be 1 over a, the nth root of a. So a to the negative 1/n is 1 divided by the nth root of a. For any two positive integers, n and m, we define a to the m over n power. Now all of this is in the exponent. M divided by n is all in the exponent. That is defined to be the nth root of a taken to the mth power. Notice if we follow rules of exponents here, this is simply a to the 1/n times m, and we get a to the m over n back again. Right, so that's why we define this like this, because if we follow the rules of exponents, we just multiply the m times 1/n, and we get this back. And that can also be written like this. We could also say we could reverse the order. We could say it's a to the mth power and then the nth root of this number. Notice if we follow the rules of exponents, we would still multiply m times 1 over n, and we would get this back. Or we could write it like this, the nth root of a to the mth power. Either way is fine. We'll look at a few examples of this in a second. Now, for two integers n and m, we also define this. A to the negative m over n power is 1 over a to the m divided by n power. And then just some notation. We've already talked about this a little bit. A to the 1/2 is called the square root. A to the 1/3 is called your cube root. A to the 1/4 is the fourth root, and so on. In general, a to the 1 over n is called your nth root. Now let's look at some examples. So let's evaluate these by hand and then using a calculator as well. So what would the square root of 16 be? Well, that's going to be 4, because 4 squared gives you back 16. So evaluate that on a calculator, of course, like the TI. Square root 16, close parenthesis off, you get 4. Now remember, in Excel, let's just look at this with Excel. Let me clear those out. In Excel, you don't have a square root button on your keyboard, so you have to type it in like this. 16 raised to the 1 divided by 2 power, like that. And you must put parentheses around the 1 over 2. There you go, 4. Or you could type it in as 16 raised to the 0.5 power, because 1/2 is 0.5, right? You also get back 4. All right, so there are two ways to do that. What would the cube root of 8 be? Well, cube root of 8 will be 2, because 2 to the 3rd power is 8. Evaluate that on a calculator. Eight raised to the parenthesis 1 divided by 3 power gives you back 2. (27 to the 1/3 power? Well, that's going to be 3, because 3 cubed equals 127. I'm sorry, 27, not just 27. Like that. 16 to the 1/4 power? That's going to be 2, because 2 to the 4th power is 2 times 2 times 2 times 2, and that is 16. Right? That's the same as 4 times 4, or 16. On a calculator, 16 raised to the, now you have to do 1 divided by 4 like this. See that? 16 raised to the 1 divided by 4, and in parentheses, the exponents in parentheses, and you get back 2. Or you could say 16 raised to the 0.25 power, because 1/4 is 0.25. Also get back 2. What would 16 to the negative 1/4 be? Well, that's going to be 1 over 16 to the 1/4 power. and so that's going to be 1 over. We've already determined this is 2, so that's just going to be 1/2. And you could evaluate that on the calculator as well. 16 raised to the negative 1 divided by 4. You have to type it in like that. You could do the same thing with Excel, and you get 1/2, 0.5. Let's take a look at 2 more here. What would 8 to the 2/3 be? Well, we have to write this as 8 to the 1/3 squared, following our rules. And so this is going to be 8 to the 1/3 is 2, because 2 cubed is 8, squared, and so this is just 4. Down here, 8 to the negative 2/3, well, that would be 1 over 8 to the 2/3, positive 2/3, and we see that that is going to then be 1/4. Check it out on a calculator. Let's do it in Excel for a change. So we would go equals 8 raised to the 2 divided by 3 power. Oops, I need parentheses. Need parenthesis around that 2 right there. Okay, there we go. And we will get back 4. If we evaluate 8 raised to the negative 2/3, like that, we get back 1/4, 0.25. And let's look at one more rule yet. This is dealing with nth roots. If you have the nth root of a times b, that is the same as the nth root of a times the nth root of b. And the same thing with fractions. If you have the nth root of a divided by b, that's the same as the nth root of a divided by the nth root of b. And another way to write these would be instead of using the root symbol, you could raise it to the 1 over n power. Or like that. So we can use this rule to simplify roots. For example, let's simplify the square root of 24. Well, notice that the square root of 24, notice that 24 is actually equal to 4 times 6, right? And so following this rule up here, this would be the same as the square root of 4 times the square root of 6, and the square root of 4 is 2, so this is going to be 2 times the square root of 6, or 2 root 6. And so there you go. So that's how the square root of 24 simplifies. It's actually 2 root 6. Oftentimes when you look up answers in the back of a math text, they will fully simplify roots like this. They won't write you won't see the square root of 24 written. You'll see 2 root 6. So just be careful when you if you look up an answer and it doesn't look exactly like what you have, you might have to simplify your answer. You may be correct. Let's look at this one, the cube root of 54. Well, 54 is 27 times 2, right? So that's the cube root of 27 times 2. And so that's going to be the cube root of 27 times the cube root of 2. Now the cube root of 27 is 3, because 3 times 3 times 3 is 27, so this simplifies as 3 times the cube root of 2. And there you go. Now just have one thing to note down here. Notice why we denote the nth root of a as a to the 1 over n power. That's because if we follow this rule of exponents, if we look at a to the 1 over n raised to the nth power, that's the same as a to the 1 over n times n, and of course that's just a to the 1, which is just a. So that's why the nth root of a is denoted as a to the 1 over n, because following our rules of exponents here, we get back a. Alright, and so that concludes our discussion of exponents.